Okay, so we're told the 7th term is equal to 78 and the 18th term is equal to 45. So what do we know? Well, I guess we don't know what A is. We don't know the first term. We also don't know what the common difference is. That's unknown. But for the first example, we know that the n value would have to be 7. It's the 7th term. And for the second equation there in purple, the n value would have to be 18 because it's the 18th term. So if I use the formula that we've been working with, Tn equals A plus n minus 1 times d, then I guess I could say for 78, that would be equal to the A value plus n minus 1, so 7 minus 1 is 6, multiplied by the d value. And for 45, we could similarly say that that would be equal to the first term A, plus n minus 1, so 18 minus 1 is 17, multiplied by the d value. So really we have two unknowns, A and D, and the only way to solve for two unknowns is to have two equations that we can work with that both contain A and D. So we have that now. So one way to solve that would be maybe to isolate the A in one of the equations. So that would be A is equal to 78 minus 6D. And for the other equation, we would have 45 equals A plus 17D. So we could isolate that A or even substitute the A in. It's really up to you how you want to do it. But I'll isolate A's here. So A is equal to 45 minus 17D. Now, when we find our values here, we would say that I guess that A is equal to A because it's the same A in both if it's the same arithmetic sequence. And so we now know that 78 minus 60 is equal to 45 minus 17D. So I'm going to bring the numbers over, and we're going to solve for the d value. The d value should be negative here, I'm hoping. So if I bring the d's to the left-hand side, I'm going to get 11d. And if I take 45 and I subtract 78, that's going to give us, 45 subtracting 78. That's going to give us negative 33. So we divide both sides by 11, and we get d is equal to negative 3. An alternate way to do that, sometimes different ways are faster. Our first equation was A plus 6D equaled 78, and the second equation was A plus 17D is equal to 45. So we can actually solve this by a process called elimination, which is actually where we just subtract the two equations from each other. So A minus A would be 0. 6D minus 17D would be negative 11D. And if we did 78 minus 45, that would be 33. And then we divide both sides by negative 11, so we get negative 3 for the value of D. So it's the same number either way. Now to get the first term, we could just substitute it in. In fact, I would encourage you to substitute into both equations because it's should be true for both equations. So I think I have some time on this video to show that. So I could say that A is equal to 78 minus 6 multiplied by negative 3. And A should also be equal to 45 minus 17 multiplied by negative 3. So here the A value would be 78 plus 18. And over here, the A value would be 45. Let's see. What's happening? 5 plus, and then 17 times 3 is 51. And if we add 78 and our 18, we should get 96. And here, of course, we get 96. Now, we're actually being asked to find term number 2, so we don't necessarily have to use the formula for this. We could just add or subtract the common difference. But to find the term, it should be the first term plus n minus 1 times d. And I'm just going to use the formula just to reinforce how we plug the numbers in. So we're finding t2 here. So our first term we now know is 96 from above, and we're doing n minus 1, so that's just going to be 1. 2 minus 1 is 1, multiplied by the common difference of negative 3. So that should be equal to 96 minus 3, which means that t2 is equal to 93. Oh, there we go. Okay, good. So I'm going to stop there. And on the website, below this video, there should be an area dealing with work you're going to hand in. And I'll assign some questions from the chapter 1. It is unit 4 for us, but chapter 1 in the book. And those questions, once again, are part of what you're going to be marked on. Okay, so take care.